All right, ladies and gentlemen, welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom video. I just totally yelled in that thing. Wow. Okay, that's going to break everybody's ears. All right, so today we're doing Unit 5 Notes number 3. We're into the second half of our Unit 5 notes. This is all about quadratic functions. And so today we're going to learn a new transformation that we didn't learn about back in Unit 2. It's going to be about vertical stretches and shrinking. But first we need to do some review. So as you can see up here, it says we worked a little bit with quadratic functions back in Unit 2 when we were learning transformations. But we need to remember the quadratic parent function is f of x equals what? What is the quadratic parent function? X squared, that's right. F of x equals x squared, okay? And so we're going to graph the parent function because it is very important that you know the parent function. Everything we do with transformations, especially in this unit, you need to know the parent function. Okay, before you guys were asking, like, how do I know what x values I choose, right? Do I just make them up or whatever? This time we're going to make it easy for you. You're always going to use the same 5 starting points. So if I were to get 5 starting points, do you know what they would be? Negative 2?
0, 0.
But what's the y value for negative 2? So negative 2? 4. Negative 1? 1. 0? 0. 1? 1 and 2? 4. That's right. And so these are going to be our basic points that we use every single time. We're going to start with these quadratic functions. Okay, so let's graph the parent function on our graph. We got negative 2, 4 right here. Negative 1, 1 right here. 0, 0 right here. 1, 1 right there, and 2, 4 right here. Okay, guys, and remember the quadratic function is supposed to be somewhat curved, okay? So make it look somewhat curved. Some people will draw like weird little swords or whatever. Yeah, because I'm making it all sharp and stuff. It's supposed to have some curve to it, you know? Guys, have some curves to it. Yeah. Okay. All right, anyways. And then so real quick, let's review domain, range, and all this stuff. And I'm going to give you some notes because some people, you know, we're not very good at this. Maybe we forgot. Maybe we never even learned it in the first place. All right, so for domain, can anybody tell me the domain of this graph right off the bat? Okay, the domain is the x values, right. So what's the domain of this graph then? No, so you're picking specific points, right? But the whole line, all of those are points, you know. So the domain here is going to be the leftmost, this is my notes, okay, leftmost to the rightmost.
So it'll be
negative, infinity. That's right. And then what symbols do I use around these? Parentheses, right. Okay, because the leftmost, does this graph ever stop going to the left? No, it doesn't. You see the arrow. So that means negative infinity because to the left on the graph is negative. And then does this graph ever stop going to the right? No, it doesn't. So that's positive infinity because to the right is positive direction. And we use the parentheses because infinity is something you can never reach. You know, you're going towards it, but you never reach it. You never touch that point. All right, so let's do the range now. What is the range of this graph?
0, infinity.
0,
Comma, infinity.
And what are the symbols around the 0?
Parentheses.
Not going to be
Oh, wait,
a
not
bracket.
Parentheses.
And then parentheses, right. Why is it a bracket around the 0?
It's a point.
Because it's a point and you're actually touching that point, right. And so a quick note for the range is going to be the lowest y value, the lowest y, and then the highest y. Right, because the lowest y value here is 0, the highest is infinity because it never stops. Okay. All right, now, here's a note for these next two. Y and x-intercept. A lot of you guys lost points on tests because you just wrote numbers. The y and the x-intercept, they're points. So label, make sure you know that for yourself. I'll label like that. Those are points. Okay, so what is the y-intercept here? 0, 0, that's right. That's right, with parentheses, because points have parentheses. Order pair. What is the x-intercept then?
0.
None? There's no place where it's touching the x-axis? 0, 0, that's right. It can be the same thing. Right, x-intercept is where it touches the x-axis, y-intercept is where it touches the y-axis, okay? And you can have more than one x-intercept. You just write both the points, all right? Okay, what is the vertex then?
0, 0.
0, 0, right. How did you know that's the vertex though, Ronnie?
It's the like bottom point.
The very bottom point, right. So the vertex is going to be that very bottom point, or it's going to be the very top point. So it's going to be a peak. It's going to be a peak or lowest point. Okay, does this graph open up or down? Up, that's right. Okay, now here's an important thing to note about the minimum and maximum. Those are values. The minimum and maximum are the y values, the lowest and the highest y values. Lowest y value. Okay, so the minimum is what? 0. And where did you get that from?
That's with the lowest y.
Right, so you're actually looking at the graph. But actually another thing you can do is, once you get the range is the lowest y and the highest y, right?
Yeah.
So you can get the minimum and maximum values straight out of the range. But if you did that, what would you say the max is?
30.
So somebody who said that, none, is none, right? Because here's another note you want to write. If it's infinity or negative infinity, then it's none. Exactly, because there's no exact point, right? It's just going on forever. All right, and then lastly, we have the axis of symmetry. What is the axis of symmetry here? Okay, so it's not, you can't just say 0. It's a line, right? It's the line that cuts down the middle. X equals 0. So make a note to yourself that the axis of symmetry is x equals a number. All right. So that's just review right there. And now let's look at this. Oh my goodness. All right, so this equation right here shows you all of the possible different transformations of a quadratic function. Okay? Because remember, the parent function is f of x equals x squared. And all of these different variables show you different possible transformations. So we're going to go through these. All right. Horizontal translation. Which variable, so which letter here shows you horizontal translations? H. And H is on the inside. And remember, the movement for horizontal is opposite. So movement is opposite of sign. So if H is positive, which way do I move?
To the left.
Right, so that's shift left. And if H is negative, I shift to the, that's right, shift to the right. Okay, for vertical translation, which letter indicates vertical translation here?
K.
K, that's right. And K is on the outside. So that K is usually tagged on at the end, but the important thing is that it's on the outside of the parentheses. So sometimes they put it at the beginning. Okay, so if K is positive,
Up.
shift up, that's right. And if K is negative,
Down.
that is right. Okay, so next we've got reflection over the x-axis.
That's on the inside.
It's on the, which letter
Oh. B.
shows you
B.
over the x-axis?
So the A.
It's A, that's right.
Oh.
A is the x-axis, but it's not just A. Okay, what about A tells you that it's reflecting over the x? If it's, that's right, if it's negative. So Edgar's saying like if it's the sign, right. If the sign is negative. If A is negative, so if A, which is on the outside, is negative, that tells you that you're reflecting over the x-axis. But also think about this. If you reflect over the x-axis, which way does your graph open? Down. Right, so open down. So you can just look at the equation, and if A is negative, then you automatically know it opens down. You don't even have to graph it. Okay? So an example of what this would look like would be like this. Examples would be negative x squared or negative parentheses x parentheses squared. You see, this second one's obvious, right? Because the negative sign's on the outside of the parentheses, right? But the first one, you don't see any parentheses, so you might be like, okay, is that outside or inside? And so make this note to yourself. No parentheses means outside. So these are pretty much the same right here. Means outside.
Oh.
Yeah.
If there's no parentheses, it's still going to be across the y-axis, like going up, it's going to be open up, right?
If there's no parentheses, it's opening down. These are the same. Both of these are reflecting over the x-axis, yeah. All right, so now let's do the reflection over the y-axis. What variable, which letter, tells me about reflection over the y-axis?
B.
And what about b?
It's on the inside.
Inside.
But what about it would tell me?
Positive?
No.
What do you mean?
Inside or outside?
No, okay, you're right, it's on the inside. But I'm saying, how would you know that you're actually doing a reflection? Because just because the b is there doesn't mean you're doing a reflection. So it's the same thing as Edgar said, it's the sign. So what sign tells you to do a reflection? Negative, right. If b, which is on the inside, is negative, that tells you to reflect over the y-axis. That doesn't change the way it opens. It's still opening upward. It just reflects it over the y-axis. Okay, so an example would be like this. It would be, for example, parentheses, negative x, parentheses squared. Or even parentheses, negative 2x, parentheses squared. In both of those, you can see the negative sign, that b is inside the parentheses. And that's how you know it reflects over the y-axis. All right, so let's do a basic example of transformations of a quadratic function, okay? So right here, look down at this example. This graph is f of x equals negative, parentheses, x plus 2 squared, plus 3. All right, so we're going to list the transformations. When you do transformations, you go from left to right, okay? So what's the very first transformation you see? Reflect over the x. That's right. And what told you that?
The negative sign on the outside.
Negative sign on the outside, right. Negative outside. What is the... Yeah, I heard that. What is the next transformation you see?
Up here.
Left to, left to. And what told you that?
The positive,
The positive,
which is opposite.
positive 2, inside or outside? Inside, right. Positive 2 on the inside told you to go left to the 2, left 2, whoa. And then what's the last transformation you see in this equation?
3.
Which means, where am I moving? Up 3, that's right. And it's that plus 3 on the outside. Okay, so we're just going to graph this as we normally would, okay? So we're always going to start with the parent, right? So look, first we're going to graph those points. Negative 2, 4. This is the parent function. And you use a pencil here because we're about to do a bunch of erasing. Negative 1, 1, 0, 0, 1, 1, and 2, 4. This is the original way we learned how to graph these transformations, right? So we put the parent function points, okay? And then we apply each transformation, right? So our first transformation is what? Reflect over the x. So I'm going to take all these points and I'm going to reflect them over the x-axis. So my new points will be here. Like that. Those orange points are my new points after I reflect over the x. Okay? So now I erase my original ones because those have been transformed. What is my next transformation? To the left? To the left 2. So now I'm going to take all of these points that have been reflected and move them all to the left 2. So right here, right here, right here, here, and here. So now I've moved all my points to the left 2 more spaces. And what is my last transformation? Up 3. So now I'm going to take all of these points and move them up by 3 units. And that is my finished product. It's my finished graph. So it's these blue points right there. And then we connect them, trying to make sure there's a curve. Something like that. All right, so let's really quickly go over the domain and all that stuff. So what is the domain of this graph? Negative infinity to positive infinity, right. The domain on quadratics is always the same because they're always facing up or facing down u's, right? They always go on forever in both directions, left and right. But what is the range of this graph right here? Negative infinity to 3. It stops at 3 because it's the lowest to the highest. Lowest is negative infinity, and the highest here is 3. And we use a bracket on the 3 because we're actually touching that point. Okay, what is the y-intercept? Zero, -1. You can see that point right there that touches the y-axis is 0, -1. Yeah. What is the x-intercept? Okay, you guys actually won't be able to tell here. Look at these red dots right here, just to illustrate where they are. So the x-intercepts are right there. There's 2 of them, right? There's 2 places that it touches the x-axis. So you don't know what they are because it's not exact. So I'll tell you, it's -3.7, 0, and -0.3, 0. If ever there are intercepts that you can't tell exactly where they are, I'll just give the points to you, okay? So, right, like that one, just giving that one to you. You're going to see on your homework, I think there's one like that as well, where I just give you the x-intercepts or something because you can't tell. All right, where's the vertex, though? -2, 3, right. Does it open up or down? Down. What's the minimum? None, that's right. And what's the maximum? 3, that's right. And lastly, we have axis of symmetry. What is the axis of symmetry? X equals? It's this line right here, right? -2. Because where does it go through on the x-axis?
Oh, okay, I see it.
Yeah. So that's how you can tell exactly where. Also, another way you can think about this, if you want to make a note of this, the axis of symmetry, it's always the same x value as your vertex.
Oh.
Because the vertex is that perfectly in the middle point, right? And the axis of symmetry is the line that cuts it in half, which is the middle line. All right, so there we go. That's the basics. This is kind of refreshing, but now here's our new transformation of the day. Vertical stretching and vertical shrinking. Yeah. So we already know that if A is negative, we reflect over the x-axis, right? But A also tells us about vertical stretches and vertical shrinking. So pay attention here because this is a whole new technique. I'm going to show you a different way to actually graph these as well. Okay, so first of all, a vertical stretch. We have a vertical stretch if the absolute value of A is greater than 1. So look at this example. F of x equals 3x squared, right? What's the A value here?
3?
It's 3, that's right. The A value is 3, and is that greater than 1?
Yeah.
Yes, it is. It's greater than 1. So this is going to be a vertical stretch then. And vertical stretches are narrower. So write that down. They get narrower than the parent function. They get narrower. Narrower. All right, so now this is a technique they're going to be using throughout this unit. Okay, otherwise you might make mistakes. But we're going to be using this table to find our finishing points. Okay, so in the table, we're always going to start with our parent function points. What are those 5 points? -2, 4, then? -1, 1, 0, 0, That's right. So we always start with that. And so this is the first time we're seeing this. So let's also graph the parent function. So right now, graph the parent function. Negative 2, 4. Negative 1, 1, 0, 0. 1, 1, and 2, 4. There we go. Okay. And now this is what we're going to do. So with this table method right here to find our final points, we're going to change the x or y values depending on our transformations, okay? So we've already determined that there's a vertical stretch here, right? Because we got a 3, this a value right here is greater than 1, so it's a vertical stretch. And real quick, are x values left and right or up and down? Left and right. And y values are up and down. So any transformations that have to do with left and right movement, we're going to change x values, okay? Any transformation that has to do with up and down movement, it's going to be the y values. Okay. So this is a vertical stretch. Does vertical mean up and down or left and right? Up and down. Vertical is up and down, right. So are we going to be changing y values or x values? Y values, that's right. Okay, so it's a vertical stretch with a factor of 3. So what do you think we're going to do to all the y values? Multiply by? That's right, so that's all you have to do. Multiply all the y values by 3. And so what are my new y values?
12, 3, 0, 3, 12.
Right, and that shows me the vertical stretch of 3. So I write over here, vertical stretch 3. I'm supposed to put VS. And then I show my new values. So those are my new y values. So now, that's my points. See, the x values didn't change, right? Only the y values. So now my new points are negative 2, 12. Negative 1, 3. 0, 0. 1, 3, and 2, 12. Okay, so obviously the negative 2, 12 is off the page, so we don't need to worry about that. But negative 1, 3 is right here. Then we have 0, 0, right? 1, 3, and then 2, 12 is off the page. And so now let's connect these and make sure it curves a little bit. And you can see this is a narrower graph than the original parent function. That's a vertical stretch. All right, so let's do the vertical shrink now, okay? If vertical stretches got narrower, what do you think vertical shrink's going to do?
Bigger.
Bigger is like very big. Wider. 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 The opposite of narrower is wider, right. Okay, so vertical shrink, you can tell if a value is between 0 and 1. So look at this equation right here. F of x equals 1/2 x squared. What's the a value there? 1/2, that's right. And is that between 1 and 0?
Yes.
Yes, it is. So this is going to be a vertical shrink. Okay? So we're going to start the same way. In our table, what do we start with? Right? Right, the parent function points. Okay? And now it's a vertical shrink, so which values are we going to change, x or y?
X.
Is vertical.
Oh, wait, Y.
Y, that's right. Vertical's up and down, so we're going to change the y values. It's a vertical shrink of 1/2. So what do you think we're going to do? Right, divide by 2, or technically you're multiplying by 1/2. And so your new y values are going to be what? 2? 0.5 or 1/2, right? 0. 1/2, 0.5, yeah. And 2, right. So these are your new points. So first graph the parent function because we want to compare. So negative 2, 4. Negative 1, 1. 0, 0. 1, 1. And 2, 4.
So negative 2, 2.
Right, negative 2, 2. The new points are going to be negative 2, 2. Negative 1 and 1/2. That's right here. Look. It's right there. Right. Oh, hold on. Wait a second. Okay. Yeah, 1/2 is in between, 0 and 1, so you just kind of put it there. Then you got 0, 0. 1, 1/2, and 2, 2. And so when you connect these points, you can see it's a wider graph than the original. You see? What? 0.5 is between the 0 and 1, so like, you see this point right here? That. Yeah, that's between the 0 and the 1. It's not actually on a line. Okay, so now that we've seen that, let's do some examples because your homework is going to look just like this. It's pretty much this all the way through. Okay, so they're giving you an equation. Actually, let me open my other page so it doesn't freak out on me. Right here. Okay, we've got the graph is f of x equals 2x squared plus 2. Okay, and so we're going to write the transformations from left to right. What's the first transformation you see here?
Negative, I mean, 2x.
The 2, what does that mean though? What are we doing?
Is out the.
Make it narrow.
Vertical
Vertical stretch.
stretch of,
2.
right, like that. So that's how you write it. Vertical stretch of 2. So that's what we're going to write. And what is your second transformation there?
Up 2.
Up 2, that's right. Okay, so now we're going to use this table to find all our points before we even graph, okay? So what do we start with in the table?
Negative 2, 4.
Right?
1, 1, 2, 4.
There we go. Okay, so what is our first transformation? Okay, so it's a vertical stretch of 2, so we multiply by 2. What are we multiplying by 2?
The y.
The y. So right up here I'm going to write vertical stretch 2 to let myself know what I'm doing. Times 2, times 2, times 2, times 2, and times 2. So what are my y values at this point?
8, 0, 0, 2, 8.
Right. Okay, and then what's my other transformation that I have here?
Up 2.
Up 2. So up 2, am I going to change the x values or the y values?
Y, x, y.
Think about it. It's up 2. Which values talk about up and down?
Y.
Y. So we're going to change the y values. And how would I show moving up 2? Add 2, that's right. So now up 2 right here. We're going to add 2 to all those y values we just had. And so my final y values are going to be what? 10, 4,
2,
2,
4,
4, 10. And so my graph is going to be at negative 2, 10, negative 1, 4, 0, 2, 1, 4, and 2, 10.
Is that the final graph?
Yeah, that's it. That's the final graph. Because you took care of all your transformations, right? The vertical stretch and the up 2. Boom, there it is. Okay, and so let's do the domain, range, and all that stuff just to make sure we know. What is the domain of this graph?
Isn't it the x of negative infinity?
Right, 2. That's right. All quadratics are the same. It's always negative infinity to positive infinity on the domain. What's the range here, though?
Negative infinity, no.
Look at your graph to see. Bracket 2 to infinity, that's right. Because we start at the 2, the lowest point is 2. The highest point, it doesn't have one, so it goes to infinity. What's the y-intercept? 0, 2. That's the point where it touches the y-axis. What's the x-intercept? None, right, so we don't have one, it's none. What's the vertex? 0, 2. And what is the axis of symmetry? X equals what?
0.
That's right, it's x equals 0. Oh, what did I write? 2. It's always x equals and the value is the same as the x in the vertex. Okay? So there we go, good. And let's do one last example, a more complicated one maybe. So this has 3 transformations. We're working from left to right, okay? So what is the first transformation in f of x equals negative 1/2 x squared minus 1? Reflect over x. That's right, because we see that negative sign in the very front on the outside of everything. There's no parentheses, so we know it means outside. What's the next transformation? What is it called?
Vertical shrink.
Vertical, what?
Shrink.
Is it a stretch or is it a shrink?
Shrink.
Shrink, because it's less than 1. It's between 0 and 1. And vertical shrink of? 1/2, that's right. And what's the last transformation here? Down 1. There we go. All right, so now watch. We're going to use this table to find everything. So negative 2, 4. Negative 1, 1. 0, 0. What the heck was that?
That's gonna be funny when they watch that. That was your voice.
0. Come on. Crazy Microsoft Word. Hello. 0, 0, 1, 1, and 2, 4.
Yes.
Okay, so what is the first transformation we have here?
Divide by 2.
All right, hang on.
Oh,
The
no,
first one.
It's
Reflect over.
over.
Reflect over x. Now think about this. Is reflecting over the x up and down movement or left and right movement?
Yeah,
Down.
Up and down. That's right. Okay, so you guys are like the first one who actually got that today. Yeah, because if you do it with your hand, right, with your hand reflecting over the x, your hand's moving up and down, right? And so up and down would be x or y.
Why?
Y, that's right. So all we're going to do with reflect over x is we put a negative sign in front of everything. We multiply everything by negative. So what are my new y values?
Negative 4.
Negative 4,
Negative 1.
negative 1,
0.
0,
Negative 1.
negative 1,
Negative 4.
negative 4. All right. So we took care of the reflecting over the x. So what is my next transformation? What am I dividing by 2, x or y's? The y's, right, because it's a vertical string. Vertical's at the y values. So vs 1/2. So divide by 2.
Would that be negative 2?
That's right, negative 2. So negative 2 and then negative 1/2. 0.
Negative 1/2.
Negative 1/2.
Negative 2.
Negative 2, that's right. And then we've taken care of now the vertical shrink of 1/2. You know, dividing by 2, same thing as multiplying by 1/2. And lastly, so we got to do the down 1, which means subtract 1 from what? X or Y's? Y's, right. So down 1. So we're subtracting 1 from all those Y values.
1.
Hang on a second. So it's negative 2 minus 1. What's that?
3.
Negative 3. All right, what's my next Y value? Negative 1.5. What's my next one? Negative 1. Negative 1.5. And negative 3. And so those are my final points right there. It's going to be negative 2, negative 3. Right there. Negative 1, negative 1.5. That's right here. It's like, okay, it's like frozen. All right. Well, 0, negative 1. Huh. 1, negative. Wow. Did you see that? Okay. 1, negative 1.5. Right there. Okay, not right there. Oh my goodness, what's going on here? And what is the last one? 2, negative 3. So your graph looks like this. And so real quick, let's do the domain and everything so we can have completed notes. So what is the domain on this one? Negative infinity to positive infinity, right? It's always the same. What's the range though?
Brackets, negative 1.
We start at the lowest possible. Negative,
One half.
negative infinity, the lowest. The lowest. That's negative infinity.
Comma.
Comma.
Negative 1, right?
-1.
Oh, I switched it around.
Yeah. Because isn't negative infinity lower than -1? Okay. What's the y-intercept?
0, negative 1.
0, -1. That's right. What's the x-intercept?
And
None. What's the vertex? 0, -1. And what is the axis of symmetry?
0.
What is it?
X equals 0.
X equals 0. You see this line right here, cutting in half, and that's x equals 0. So that is it for today's notes. So that is it with the notes number 3 with 5th period.
The outro.
See ya in the next one. Peace!